Okay, so we're all pretty comfortable with describing angles with degrees, but there is another unit of angle measurement that some of you may have worked with previously, some of you might not have, but they're called radians. And radians are described as the measurement when this arc length, or the length of this measurement along the circle, is equal to the length of the radius of the circle, or 1/2 of the diameter. And so the circumference of the circle is 2 pi. And so when I am measuring in radians as an angle measurement, I'm going to take that full circumference, because remember, a full circumference like this is 2 pi, but it's also 360 degrees. So this is going to be measured as 2 pi radians, or 360 degrees. Those are equivalent angle measurements. So if I divide 360 in half, or 180, that gives me pi radians, or 1 pi radians, which makes it really easy to convert between degrees and radians. So pi radians equals 180, 180 equals pi radians. So when I'm converting degrees to radians, I'm going to write it as radians equals, and then I'm going to do the number of degrees times pi radians over 180. And so in this, the degrees cancel, and I'm left with a number of pi radians. So the degrees times pi radians over 180, because even though these are different units, they have the same value, so it's a factor of 1. So pi radians divided by 180 is equivalent to 1. It just is a unit conversion for us. So then working in reverse, radians to degrees, we write this as degrees equals radians times 180 over pi radians. 180 degrees over pi radians. So then the pi's would cancel, and I'd just be left with degrees. So radians, pi radians, times 180 degrees over pi radians, pi's would cancel, and I'd be left with a numerical number. So let's see a couple examples of this. So if you look at number 7, flip your sheet over and look at that first question, converting degrees to radians. We have 60 degrees, and we want to convert it to radians. So I'm going to use this first formula, so 60 degrees times pi radians over 180 degrees. So the degrees cancel, and I'm left with 60 over 180 times pi radians. And so when you put this in your calculator, or if you're simplifying, you might say, okay, well, I can cancel those zeros, I can cancel out a factor of 10, and then I'm left with 6 over 18, and I know that 6 goes into 18 3 times, 18 divided by 6 is 3, so I know I'm going to be left with 1 over 3 pi radians, which simplifies to pi over 3 radians. Or you can put it in your calculator, you can do 60 divided by 180 and just know that you have a pi radians as your unit here. You can put this in your calculator, 60 divided by 180, and that's going to come out with 0.3333 repeating. And then you can click the math button, and then click the frac button, and that will give you 1/3. So you've got 1/3 times pi radians, which is the same thing as pi over 3 radians. So you can either simplify using your brain power, simplify using calculator power. So number 13 is an example of converting radians to degrees. So I'm going to use the second formula here, radians to degrees. So I take the number of radians times 180 over pi radians. So I've got 5 pi over 18 times 180 over pi radians. So the pi's cancel, and I'm left with 5 times 180 over 18. It's going to be a degree sign there. And so again, you can either put this in your calculator, 5 times 180, then divided by 18, or I can see that a factor of 18 goes into both of these, and then I'm left with 50 degrees, because 180 divided by 18 is 10, 5 times 10 is 50. All right, so take a second to pause this video. I want you to do number 8 through 12 and 14 through 18. So pause this video and do those problems, and I will roll you over to the answers in a second. All right, so here are the answers. So 8 through 12, we're converting degrees to radians. So your answers are all in boxes up there. And so for this, I am reminding you that you'll get 160 pi over 180. So put 160 divided by 180 into your calculator, and then you'll get a fraction, and then you can press math and then fraction, and that will give you 8 over 9. So it's 8 over 9 times pi radians, or 8 pi over 9, because I'm multiplying the numerator by the pi. Same thing with number 9. I have 330 times pi over 180. 330 divided by 180 gives me 1.8333. I put that in my calculator, math, the math button, scroll down to fraction, and that gives me 11 over 6. That's 11 pi over 6. You can do the same exact thing with negative numbers. You just have to put a negative sign out in front. So then 14 through 18 are our radians converting to degrees. So for number 14, I have 11 pi over 9 times 180 over pi. So my pi's cancel, and I'm left with 11 times 180 divided by 9, and that gives me 220 degrees. If there are any questions about any of these answers, please feel free to reach out. You can pause and write these in and correct your sheets. So the last thing we're going to learn about are coterminal angles. And so we started this topic by talking about initial rays and terminal rays. And when two angles, or when angles share a terminal side or a terminal ray, remember that the positive x-axis acts as our initial ray. When two angles share their terminal side, they're known as coterminal angles. And like co meaning like a shared responsibility, or shared, something that's shared between things, like co-parenting, co-existing. So they're coterminal angles. And so in this example, and you can see that on the left here, 90 degrees, which is drawn like this, counterclockwise 90 degrees, which in radians is pi over 2. It's pi over 2 radians, because 90 times pi over 180 gives me 1/2 pi, or pi over 2 radians. 90 degrees shares a terminal side with negative 270 degrees. So if I draw my clockwise angle negatively around the origin, 270 degrees, or negative 3 pi over 2, they share this terminal ray here. So how do we calculate those? Well, to either angle, we can add or subtract 360 or 2 pi, because remember, 360 is equal to 2 pi radians. 2 pi radians is the same thing as 360 degrees in angle measurements. So if they match, so if I add or subtract 360 or 2 pi to either angle, and if they match, they're coterminal. So 90 minus 360 gives me 270. 270 plus 360 gives me 90 degrees. 3 pi over 2, negative 3 pi over 2 plus 2 pi gives me pi over 2. Pi over 2 minus 2 pi gives me negative 3 pi over 2. So we'll calculate, I'll erase this because I'm probably a little confused. So let's calculate, let's see, 19 through 22 are asking if they are coterminal. So literally what you have to do here is you take the first angle measurement or the second one, your choice, and you see if you add or subtract 360 from it, will you get to the second angle? So in number 19, because 55 is less than 305, I'm going to try subtracting. So 305 minus 360, that gives me minus 55. So these are coterminal angles. And you can do number 20 with 30 and negative 170 and see if they work for that one. Yes, and your answer will be yes or no. In number 21, this is where we're adding or subtracting 2 pi. So I have pi over 4 and negative 9 pi over 4. Because this is less, I'm going to subtract 2 pi from this, so pi over 4 minus 2 pi. And what I'm going to do here is I'm going to find a common denominator. So I have to multiply this by 4 over 4. So pi over 4 minus 8 pi over 4. That gives me 1 pi minus 8 pi equals minus 7 pi over 4. So those do not work. These are not coterminal angles. And you can try 22 using the same process. And so then 23 through 28 are asking us to find the coterminal angle to the angle measurement that's given. So in 23, they give us 150 degrees and they want us to find the positive coterminal angle and the negative coterminal angle. What this means when I'm finding the positive coterminal angle is I'm adding 360 or 2 pi to that number that it gives me. When I'm finding the negative coterminal angle, I'm subtracting 360 degrees or 2 pi radians from that number. So 23, to find the positive coterminal, I do 150 plus 360, and I get 510 degrees. For the negative coterminal, I do 150 minus 360, and I get minus 210 degrees. 24 and 25 work exactly the same way using degrees as units. For 26 through 28, we're working with radians. So to find the positive coterminal angle here, I would do pi over 12 plus 2 pi. And I can either change this measurement, or I can change this denominator, or I can just take this, this denominator and multiply it by this 2 and know that this is 24 pi over 12. So what I'm going to do is I'm actually going to change the denominator so you all can see it. So I've got pi over 12 plus 24 pi over 12. Because 24 divided by 12 is 2, so these are the same. And that gives me 25 pi over 12. And that can't be simplified any further. There's nothing that goes into 25 that goes into 12 except for 1. So then the negative coterminal, pi over 12 minus 2 pi, again, I would multiply this by 12 over 12 to get the same denominator, so pi over 12 minus 24 pi over 12 gives me negative 23 pi over 12. And again, that cannot be simplified, so that would be my answer. So really quick, if you were wanting the answers to the questions, so question 20, 22, 24, 25, 27, and 28. I want you to do those questions. So the answer to 20 is no, not coterminal. 22 is yes, they are coterminal. 24 is 625 degrees and negative 95 degrees. Number 25 is positive 335 degrees and negative 385 degrees. 27 is 19 pi over 6 and negative 5 pi over 6. And then 28 is 25 pi over 18 and negative 47 pi over 18. That one is more challenging. using the higher number denominator. So these are your answers to all the questions that we did not go over. If you have any questions or concerns with this and you need a little bit more practice, please reach out to me and I will get to you as soon as I can. Thank you.